Hello and thank you for watching this video tutorial on OSForensics by PassMark software. OSForensics is a feature-rich, versatile, and robust computer forensic software used by cybersecurity and digital forensics professionals around the world. In today's video, I'm going to demonstrate how to acquire a process-specific memory acquisition using the Memory Viewer module in OSForensics. The Memory Viewer module is located here in the OSF workflow, and when you click on it, it will display all running processes on the host machine. So this obviously is a feature that was implemented for live analysis, or sometimes referred to as triage. This new feature was added into version 4 along with several other major improvements to the Memory Viewer module. So as you can see, there are now 47 columns of metadata for each running process. In addition to these columns, there are also 5 tabs of additional information pertaining to each process, such as the process info, handles, modules, memory space, and memory layout. Now, most of us are familiar with the traditional memory image acquisition, otherwise sometimes referred to as a RAM dump. This is when someone takes an entire binary image of a system's RAM. They are grabbing literally everything that's present in that volatile memory. This is nice to have, and you can certainly easily do that with OSF by simply clicking on the Dump Physical Memory button that's located here along the top section of the window. All you would have to do is assign this, after clicking on it, is literally just assign it a name and click Save and give it a location, and you're off and running to creating a full memory acquisition or RAM dump. The problem is that acquiring a memory image over USB can take an incredibly long time to complete often. This problem is compounded when you factor in today's computers have larger amounts of RAM than ever before. So unfortunately, many people just flat out won't do this because of the time constraints. And this is why we have developed a new methodology of acquiring a binary snapshot of memory by allowing users to selectively target specific processes in the memory and acquire binary images of this process-specific data, which takes mere seconds to complete, compared to the sometimes hours-long wait for a traditional full memory acquisition or RAM dump. So let's take a look at how you can do this. So first we need to find a process of interest. So for example, we could use a web browser. So like here we can see chrome.exe. Maybe if you came across something like Tor, the onion router, tor.exe, maybe if we saw that running, we'd probably want to take that. For this example, I'll go ahead here and use Chrome. And so once you've selected a process of interest from the menu, go ahead and right click on that process and then move your cursor over the export process to disk option, which will then display a few more options, including the one we want, which is the process memory snapshot. And this is the option we want to choose in order to obtain our process specific memory image. So once you've selected it, you will just give it a name if you want to change it from what's the default name that OSForensics is giving it, and just either confirm that storage location is okay to save it to, or go ahead and change it at that time. And if we go ahead and take this snapshot in real time here, you can see just how quickly that it occurs, and there what you saw was maybe literally 2 seconds of time. So it's very minimal time to complete in comparison to a full memory snapshot, which we might be here for an hour or more. On this particular system I'm using with 16 gig of RAM. And that's about it. So now you have a binary process specific memory image that's ready for further analysis. And one very fast and simple way to process these images with OSForensics is to just open them up with our file viewer, the OSForensics file viewer, which is located on the start screen and it's called right here the File and Hex Viewer. If you want to go ahead and click on that, you'll just go and point the file viewer to the location of your process-specific binary file that you've stored. So in this case here, let's use one, and what it'll do is open it up under the hex/string viewer tab, and a simple automated thing that anyone can do with these is just hit the extract strings button. And what this does is go along here and it'll try to find anything that it sees in ASCII and pull that out and display it to you over here in the viewing column, at which point you can do keyword text or keyword searches in real time, as well as even filter down the results to things such as file names, URLs, or even GUIDs or GUIDs. You can further get a little more granular by going into the settings, and as you'll see, by default the max strings results is 50,000 strings. You can bump that up to 1,000,000 if you'd like to. You can change some of these settings as well, and as you will see, even if we bump this up to 1,000,000 strings, now we're not going to get those immediate results, but as you can see here from the search status bar, that it just takes a very short time. Now, we're still getting truncated results here, and let me remind you that was after changing that to 1,000,000 strings. So that was one specific or one process specific binary image that we acquired from running memory in a matter of seconds, and now we've got such a large data set here. And we can sit here, we can scale down to all these URLs, maybe find some URLs or websites of interest, maybe some file names. Maybe if we were looking at that tor.exe binary image, maybe we're going to see a lot of IP addresses and various things from the Tor browser that's running in memory. So very, very handy, very, very fast, and like everything with OSForensics, very, very simple and user-friendly. Thank you for watching this tutorial on OSForensics. If you have any questions or comments, please feel free to contact us by email at info@passmark.com or visit us on the web anytime at www.osforensics.com.